Hello everybody, this is Sachin Hulagiri. Let's continue our discussion on statistics and data science. Today we are going to discuss about central tendency. This comes under the descriptive statistics. As we know, there are two kind of statistics. One is the descriptive statistics and there is inferential statistics. Let's see the central tendency in descriptive statistics. So the topics covered in this session are measures of central tendency, mean, that is arithmetic mean, median, mode, merits and demerits of mean, median and mode, standard deviation and variance, and how to calculate all these central measures from R. Let's go further. What is central tendency? The central tendency is the property of concentration of values around central value in the data. For example, if I want to know a central tendency of a classroom with respect to height, we call a classroom has an average height of 4 feet 10 inches, like that. It's the 4 feet 10 inches. The value is it may be an average value or most of the people who are at the 4 feet 10 inches. That is called as a central value. It's like a central concentrated value, which is nothing but a central tendency. Okay, let's see the objectives of for a central tendency. To get a single representative, as we discussed, like there are set of students in a classroom. We want to give a single representative of the class. In this case, we will use central tendency. So it's nothing but it's a representation of a single representation of a mass data. Measure of central tendency enables us to get a single value from the mass of the data and also provide an idea about the entire data. To facilitate a comparison, the measure of central tendency enables us to compare two or more than two populations by reducing the mass of data to single figure. For example, in generally we tell the literacy rate in the country. When we compare between states to another state, we'll tell this is a 60-70% of literacy rate in this particular state, and this is a 70% of literacy rate. So that will take a central value of the thing of the population, and it's a average. It's a single value that represents the entire mass. Basically, central tendency is more like an average kind of data. There are some characteristics exhibited by central tendency or a good average. When we call it as a good average, it should be easy to understand and simple to calculate. Good average should be based on all the observations. Good average should be well defined by mathematical formula. Good average should be capable of further algebraic treatment. Good average should be possess a sampling stability. Okay. Next, let's go to next page. Okay, let's see the one by one all central tendency measures. Let's see the mean. Mean or arithmetic mean, both are same. It is a sum total of all the observations divided by total number of observations. It's denoted by x bar. For example, if x1, x2, x3 and xn are the n observations in a data, then mean will be calculated based on like a x bar, which is nothing but a summation of x divided by number of observations, that is x1 plus x2 plus x3 till x1 divided by n. Let's see with some small example. Let's calculate the mean temperature for 10 days. Observed temperatures are like 32, 34, 35, 36, 36, 36, 38, 40 and 42, 42. The number of observations are 10. So here the total sum of observation is 371, and the mean value of the temperature is total sum of the temperature values divided by number of observations, that is 371 divided by 10. This is nothing but a 37.1. This represent average in the last 10 days. There is a temperature was 37.1. One day it may be 42, another day it may be 32. When we consider average, we will tell common representative of the temperature as a 37.1. Okay, so let's see the median. Median is the middlemost value of the data when they are arranged in an order. Median divides the whole distribution into two equal parts. Median is denoted by m. So when we have a set of data, and when we arrange it in an ascending or a descending order, the middlemost value is known as a median. As data is arranged in an order and we are taking the middlemost value, it divides the whole data set into two parts. Let's see the calculation method of how we can calculate median. Median calculation method. Case 1, like when the number of observations are odd, then we'll take the middlemost value of the number as a median. Either when it should be ascending or a descending order. The data should be arranged in a descending or ascending order. We'll take a median, middlemost value. Here we have 9 observations and the 5th observation comes in the middle, so we'll take it as a median value as a 6. Suppose we have a even number of observations. In this case, we will here we arrange the data in ascending or descending order, and we'll take the middle most of the two values. For example, here we will take the 5th and 6th values, and then when we divide by 2, which is the arithmetic mean of the middlemost values, that is nothing but a 6.5. Mode. Mode is a value which occurs most frequently in a data set observations, and around which there is a maximum concentration of the values. It is represented by Z. For example, marks of the students 22, 36, 38, 46, 47, 36 and 36. Here the value of mode will be 36 because it appears more than 3 times in a data set. There are two kind of modes. So one is a unimodal and another is multimodal. Let's see the unimodal. Unimodal is a data set having only one value with the highest frequency, like this above example 36. And multimodal is a data set having more than one value with the highest frequency. Suppose if it's 46 and this 47 are also like 38, it has the same 38, 38, 38, then this will become bimodal, where the two values will have a same frequency, which is highest in the data set. Mode can also be calculated by using mean and median. Mode is nothing but it is represented by Z, and it is a 3 times of median minus 2 times of mean. That is the value we use to calculate. Let's see the example of the student's example here. What we calculated: 22, 36, 38, 46, 47, 36, 36. Here the mean value is 37.28, and the median value, which is the middlemost value, it is 36. And the mode will be as per the formula. We'll calculate 36 into 3 into 36 minus 2 into 37.28 is 108 minus 74.55 and then 36.34. So you may be confused here. You may be thinking that why this is 34.3, how can we represent a mode? Here we need to consider the nearest value for 33.4 44, that is 36. This is called, this will be treated as a nearest value, and this will be a mode value. Let's see the next example. Let's see the merits and demerits of a median, mode. So merits, measure of standard tendency mean. Merits of the mean is easy to understand and simple to compute. It's based on all the observations, well defined by mathematical formula. What are demerits here? It is affected by the abnormal extreme values, cannot be used for qualitative data, generally not performed for skewed data. Here in case of like it is abnormally affected by extreme values means, suppose if I take a average salary of a company, when I consider CEO salary and other people salary, we'll get two different means. So because CEO salary will be highest, that itself will change the value of mean, and it cannot be used for qualitative. For example, he is more intelligent, less intelligent, these are the qualitative data, attribute level data. So we cannot use mean of this one because it's a arithmetic mean. It's a total sum of the value and divided by numbers of observations. So it is not possible to use a qualitative data. So let's see the median. Easy to understand and simple to compute. Median is like a middlemost value of the data, so it is easy to compute and as well as easy to understand. Not affected by abnormal extreme values, because as we solve the data and it will not be affected by any observations. Can be used for qualitative data. For example, when we take for a survey, it will be like a very bad, average, good, very good. And here good is the middlemost median value because it's easy to represent in a qualitative data also. There are some demerits of the median. That is not all observations. It is not based on all observations because it is considered only middlemost value of the data. So it will not depend upon the all observations. It is affected by sampling fluctuations. Suppose if when we do a sampling, when there is a random sample happens, no, there is no guarantee that we will get a median value is nearest to that one every time, because it based on a sample. When we solve the data in whatever we captured in that sample, that only it affects. For example, if I take a sample which in which the data lies between 1 to 20, the middle value within less than that part only it will come. In that values only it will come. But if you take the another sample which is 50 to 60, at that time we will lose the, when you take a median value, it lies in between 50 to 60. So we cannot compare these two things. Cannot be used for further mathematical treatment. Just it's to understand what is the median value. That's the only thing, understanding purpose only. And what is mode? Mode is like easy to understand, simple to compute, and not affected by abnormal extreme values, and graphically found. So means like it is also like same like a median. Here where the concentration is more, that only it is considered. Even it may be a start point or end point or a middle point, anywhere it may be. And mode is not all based on all observations. Suppose you have a like one frequency, it is having one particular value which is coming for more than highest frequency. At that time we'll consider that one as a mode. It is affected by sampling fluctuations. When again it's the same like a median, it will also affected by sampling fluctuations. Not stable as arithmetic mean, because we cannot, since it depends upon the like number of frequencies occurring, we cannot consider it as a stable as arithmetic mean. So let's see the standard deviation. It's a very popular concept in statistics. Standard deviation, it is a positive square root of the mean of square deviations of given observations from their arithmetic mean. Means we will take a deviations values from arithmetic mean, how much the value is deviated from the average value, then we take a square root of that. Positive value of that value is called as a standard deviation. It is denoted by sigma. Then we can calculate the standard deviation for grouped, ungrouped and grouped data. When we take a grouped data, we'll use a frequency, number of times how the data is, how many times it occurred. So there's the only difference here. Here x represents the value, actual value, and x bar represents the average value. It's nothing but a mean, and n is the number of observations. We'll take a positive value of the square root. When we do a square root, we will get always plus or minus, but we take a positive value. For example, we have a data 10, 11, 12, 13, 16, 17 and 19. Here the number of observations is 7 and the total sum is 97. The mean value is nothing but a 14. And let's calculate the standard deviation for this one. What we'll do here, each value, observed value, will be deducted, is going to be deducted by mean value. Means 10 minus 14 of that square and 11 minus 14, like this we'll take it, and then whatever the value it comes, total sum, and divide by number of observations. The final value is come like a 3.11. This is a standard deviation. Means the standard deviation of data from central value for that is 3.11. Standard deviation, it exhibits certain properties. For any set of the values, standard deviation will be greater than 0 because we take a positive square root of it, value of it. And the standard deviation is independent of origin. Origin means origin means standard deviations remain same when observation is increased or decreased by a constant quantity. When we promote the data with constant quantity, that standard deviation will remain same. It will not change, because there also we'll take it from the central value, mean, and then further we will take a differences, so that will not change. Standard deviation is depend on the change of scale. Mean deviation, it is multiplied or divided by constant quantity. Then standard deviation will also have a similarly affected. There are some merits and demerits with the standard deviation. Merits, it is standard deviation is on all the observations. Here we consider all the observations, and it is well defined by mathematical formula. And the demerits of standard deviation, it is difficult to calculate, because when we have a smaller data set, it makes sense. When it is too much big data set, it's very difficult to calculate the average, and then every observation we need to subtract with the mean value, and then we have to take a square root of that one, square and square root of that one. It is affected by abnormal extreme values. When you have a like abnormal extreme values, it will be affected. And the variance. Variance is another important concept in statistics. What is variance? Variance is the average square of deviations of values taken from the mean. By taking a square of deviations, it's better technique to get rid of negative values, negative deviations. When we take a square, we'll come out from the negative variations, negative deviations, which may end up in the zero sum. It is nothing but a square of a standard deviation. If we know standard deviation, when we can easy to calculate a variance, and vice versa. For ungrouped data, the variance is represented by sigma square, and it is nothing but a summation of x minus x bar whole square divided by n. For group data, we will add a frequency, which is the number of times, how many times the data is occurred. Note, this also exhibits the same merits and demerits of the standard deviation, because it's nothing but a square of the standard deviation. Okay, let's see how we can calculate using R. R is a statistical tool which is used to perform statistical modeling and then statistical analysis. Let's see, we will load the data, some of the data into a collection of data into data 1, and then we'll take a mean, which is 37.1. This is same data what I took it in an example, and the median is 36. When we give the median, it will give automatically this value. Standard deviation is 3.34383. and the summary of the data when we calculate, we'll get a minimum value, it is 32, and the first quartile value is like 35.5, and median value is 36, and the mean value is 37.1, and third quartile is 39.5, and maximum value whatever we have observed here 37. So this completes the descriptive statistics part of it, and thank you.